Hello everyone, I hope you are all having a good day today. My name is Pranay Deep, a student from Sri Venkateswara College of Engineering, Bengaluru, and today I am going to discuss about implementing a simple C program to calculate the greatest common divisor of two numbers. So without waiting any further, let us begin. So we have the introduction here. In this presentation, we will explore how to implement a simple C program to calculate the greatest common divisor of two numbers. Understanding GCD is essential in various mathematical applications, including simplifying fractions and number theory. So what is GCD? The greatest common divisor of two integers is the largest integer that divides both numbers without leaving a remainder. It is fundamental in number theory and is often used in various algorithms, such as those for simplifying fractions. Mathematical approach. One common method to calculate GCD is the Euclidean algorithm, which uses the principle that the GCD of two numbers also divides their difference. This method is efficient and can be easily implemented in C programming. C program structure. A typical C program to calculate GCD consists of input for the two numbers, a function to compute the GCD, and output to display the result. Understanding the structure is crucial for effective coding. Code implementation. Here is a simple implementation of the GCD function in C. The function uses recursion to apply the Euclidean algorithm, demonstrating how concise and powerful C can be for mathematical computations. So we have the code here. Let us see that. First we have int main function. Inside that we are declaring 5 variables, which are number 1, number 2, a, b and temp. Then we have printf and scanf for assigning values to number 1 and number 2. Then we have a is equals to number 1 and b is equals to number 2, and we are using a while loop here. Let me explain why. So first number 1 and number 2, these are the numbers which are input by the user. Then a and b, these are used to store the values of number 1 and number 2. During the calculation, we set a is equals to number 1 and b is equals to number 2 at the start. Then we have the temp variable, which is temporary variable used to store the value of b before updating it. So how the program works? The program first takes input for number 1 and number 2, then it assigns number 1 to a and number 2 to b to facilitate the Euclidean algorithm. Then the loop continues until b becomes 0, at which point a holds the GCD. Finally, the program outputs the value of a as the GCD. So let us see the explanation properly. This program calculates the GCD of two integers using the Euclidean algorithm, all within the main function. It starts by reading two integers from the user and assigns them to variables a and b. The algorithm repeatedly replaces the larger number with the remainder of its division by the smaller number, swapping their values until b becomes 0. At this point, a holds the GCD, which is then displayed to the user. This approach is efficient and uses a loop to find the GCD iteratively. So we have the algorithm here. First we will start, then second one is input two integers number 1 and number 2, then third we are initializing two variables. Inside that we have two variables, so where we set a is equals to number 1 and b is equals to number 2. Then we are repeating the following steps while b is not equals to 0. So set temp is equals to b, which stores the value of b in temp. Then set b is equals to a modulus b, which computes the remainder of a divided by b and assign it to b. Then we set a is equals to temp, which assigns the value of temp to a. Then we have the output, the value of a. This is the GCD of two numbers. Then we are ending the program. So testing the program. After implementing the GCD program, it is important to test it with various input values to ensure accuracy. Testing helps identify edge cases and validates the correctness of the algorithm. So we have the output here. First we will input two integers 48 and 18. So the GCD of 48 and 18 is 6. So we can see that our code was correct. So common applications of GCD. The GCD has numerous applications in cryptography, fraction simplification and algorithm design. Understanding how to calculate GCD efficiently can enhance problem solving skills in many computational fields. So we have arrived at the conclusion here. In this presentation, we discussed the implementation of a simple C program to calculate the greatest common divisor. Mastering this concept is vital for programmers and mathematicians alike, providing a foundation for more complex algorithms. So with that, I would like to conclude my video here. I hope you all understood my point here in this video, and I hope to see you soon again. Thank you.